All right, it looks like we're ready to go. So I want to tell you a little story. About 3 years ago, I was the Expedia Global Consumer Payments BI team. And I was working my way through highly normalized relational data. People come to me and say, hey, I need you to do this, such and such. And I'd spend weeks or days and cobble together some kind of a report for them. And I quickly became the bottleneck. Well, I wasn't really the bottleneck. The fact that I didn't have a data mart was the bottleneck. And so roll forward now approximately 3 years, and we have AWS completely in the cloud data mart solution with a Tableau front end. And we have a high level of confidence in that data that we can give it to our users. We can go ahead and let them explore the data on their own, and I'm no longer the bottleneck. I actually spend a lot of my time doing analysis. So my name is Tad Buman. I'm a senior business analyst with Expedia, Global Consumer Payments.
And I'm Anna Turk. I'm a BI solutions architect, also with Expedia Global Payments.
So today we're going to tell you a little bit about who we are and why we built this data mart. We're going to tell you in some detail, Anna's actually going to tell you in some detail about the platform that we created. And then I'll talk a little bit about the product, which may surprise you, what the actual product that we delivered is, and then also why our product allowed us to expose our data for self-service analytics. So I don't know how many of you saw Mark Rochas this morning, but he's talked much more eloquently than I will about Expedia and that we're a global leader in the online travel. He stole a little of my thunder, actually. But Expedia does business in over 200 countries, almost $3 billion of revenue, and millions of transactions just in Q3 of 2017. The reason that the Expedia Global Consumer Payments Group is around is because we need to optimize payments. So if you, as a qualified customer, come to our site and want to buy travel, we want to make that simple. We want to make sure that that payment transaction goes through successfully. And also, processing, for any of those of you that are in any kind of e-tail or retail, you understand that processing transactions is incredibly expensive. Everybody wants a little bit of the pie. The gateways, the acquiring banks, the actual issuing banks, all those people want a little bit of money. So we want to make sure that we understand who we're paying and how much we're paying to them and optimize the costs. And finally, as I mentioned in my opening remarks, the transaction systems are not necessarily built for reporting. They're, in fact, not at all built for reporting. They don't even have a little bit of an inkling of being built for reporting. They're built for being read to and written to quickly. And so we needed to have a system that was actually built for reporting. So 3 of the things, the strategic topics that we want to talk about today is think about guiding principles. This is one of the things that we did early on when we started building a data mart, and it really helped us to keep our focus, our architectural focus, right where we wanted it to be at all times. We always referred back to the guiding principles. Anna will tell you a bit more about those later. But also, with our guiding principles, it allowed us to provide enduring value over time. Also, it took us a little bit of time to understand the impermanence, to embrace, I guess, the impermanence of the cloud. And I've actually been to quite a few sessions so far. This isn't something new to anybody here, but turn off the lights when you don't need them. It's no more rack and stack and let it run all the time. And then also your end product should be usable and familiar. We went to great lengths, actually. We kind of replaced SQL Server Analysis Services Cube and Excel pivot tables, and we moved completely to the cloud and Tableau. Totally different software and hardware and paradigm. And we went to great lengths to try and make something that the users could open and see and immediately recognize and say, oh, I see this data, I understand this data, I can move forward.
So I'm going to talk a little bit about
Wait just a minute, Anna. So I got to introduce Anna. This is Anna Turp. And so again, it was about a year and a half ago, I guess, we released our first version of our data mart, and we had data in Redshift, and I was sitting and watching this spinny thing, and I was watching the spinny thing that I actually wrote a song about the spinny. It had like 5 verses in it, right? And I'm not going to sing it for you, don't worry. And then we hired Anna, and she already kind of knew what she was doing, and she came in and she said, oh, I've got to do something with the key thing and something else with the sort thing. And all of a sudden, everything started working really fast. So Anna not only came to us knowing what she was doing, but she's really awesome at what she does.
Thank you, Tad. So our guiding principles. These were, guiding principles were established before the project began, before any development was started. And it was guidelines that the team could refer back to as the project progressed. And it provided a framework for making those key decisions and ensuring that the architecture that was being built was on track. So the first thing we knew we needed was that transaction level data and not aggregated data. And this is really important because when you go to build future KPIs, you need that atomic level data. It's also important for deep investigation down to those individual transactions. And Expedia's roadmap communication included the cloud, so we wanted a cloud-ready technology. So the team was designing and evaluating solutions that could run on-prem and then be moved to the cloud. And they actually exceeded this expectation by delivering a full cloud-based solution. And in part, this was successful because they used AWS to test all these new technologies. And then standard loosely coupled interfaces. So I'll be talking about this a lot throughout the presentation. And if you've gone to any of the other BI architectures, you will hear this, decouple your components. And this is really important. You don't want tightly integrated components. As you bring on new data sources or you change your technology, you want to be able to do that without having to rewrite other components. And then scaling horizontally, we want to take advantage of AWS's ability to dynamically scale and have distributed processing. So with big data, as your data volumes grow, as you bring in new data sources, you want to be able to handle that without having to change your platform. And then self-service analytics. It was really important that our users had, access, usability to the data, quick access. And Tableau Online really enabled our users to, look at the data for hidden patterns, irregularities, and do a lot of that, gain awareness of the data themselves without direct assistance. As you heard Tad's opening comments, he's an expert in our payment process. I mean, he's in that transactional system. So it was really important that Tad and the team could be free to do those deep analytic tasks and not, be writing reports and answering kind of questions that users could discover on their own.
My job's way more fun now.
And now I'm going to hand it back to Tad to describe the product.
Okay. So let me give you a high-level overview of the product. And this is where I think you may be a little bit surprised. I'm not going to show you a bunch of cool Tableau reports that we've written, although we've written a lot of cool Tableau reports. But what I'm going to show you is the actual value that we added as a BI team. So we engineered fact tables, and I'll tell you about this a little bit more later, but our tables, we didn't just take the atomic level data. We do have atomic level data, but then we also engineered fact tables that made sense in business terms. We then also manage metrics, so we know that all of our users will be using certain KPIs, and we wanted to make sure that those KPIs were calculated the same way every time. And then finally, we used our engineered fact tables and our managed metrics and put them into managed data sources. And we did this all in Tableau Online. So we have complete control over being able to publish our data sources and so forth, and to whom we grant permissions. And then we also have, of course, reporting. What business intelligence would ever be complete without reporting. We have your standard parameterized reports that everybody knows about. We've also built pivot builders, and I mentioned earlier that the Excel spreadsheets and pivot tables were what was used before. So we created a paradigm in which our users we had our dimensions and measures in an actual report that was kind of an editable report that they could actually create and design different types of data sets. And they can do that with both a report, just kind of a tabular report, or they can do that with a chart builder. And then finally, because we have engineered our fact tables, managed our metrics, and managed our data sources, we have a really high level of confidence in our complete data set that we can go ahead and open that up to our users and give them start from scratch editable templates in Tableau Online. So without all of those kind of safeguards, we might be a little, well, you know, you can open this up, but don't do this, and well, you got to be careful about that. We don't have any of those. We don't have any of those types of things. So with that, Anne is going to tell you all about the architecture and how we got this wonderful data from where it was to where it is now.
So I joined the team shortly before the production release, and one of the things I was excited to see was the implementation of a data lake and the use of S3 as the data store. And again, if you've gone to some of the other sessions, you should see some kind of a similar pattern emerging in our architecture. And we really break it down into, when we talk about the architecture, we talk about 4 components. We talk about collection, where we either generate or collect the JSON data files and upload those to a central S3 location called the landing zone. From the landing zone, our transformation and data store component then processes the data through loading the data lake to then loading the data mart. And all of this is done on using Hive on Hadoop with an EMR. This orchestration is done using AWS data pipelines, and we execute bash shell scripts and HiveQL to actually process the data. And once we've loaded the data, our information delivery component is Redshift. So then we load that data into Redshift, where Tableau Online then accesses it. So before I go into a little more detail about the components, I want to talk about our build strategy. What we did was identified the high-risk components first. Number 1 was information delivery. So we really wanted to make sure that we could deliver the data fast and reliably. So this was the first thing that we prototyped. So we actually used AWS to prototype Redshift and various tools. Then we identified the second risk as the transformation and data store. So looking at the cloud-ready technology, we needed to evaluate all these different options and make sure that we could find one that was scalable, fast, and again, reliable. So it was a lot of prototyping done on both of these components. The other thing was to, again, make sure that they were loosely coupled to each other so we could do independent development and do as much as development in parallel as possible. And then justifying that complexity, I'm going to talk about that a little bit later, but the overall architecture looks a little bit complex, but we wanted to make sure that each component was as simple and robust as possible. So let's talk about collection. So our initial data source was an on-prem SQL server. And so what we did was we generated JSON data files and then moved those up to a landing zone in S3. And I don't want to pick on Tad, but Tad...
I feel like I might be getting picked on.
Tad did have some concerns that this was over-engineered. You know, why are we extracting JSON data files from a perfectly good database? And it's a good question. And the reason we did this is, again, we didn't want to have our ETL connected directly to that source system. Because what happens is that when you change that source system from a SQL to an actual external Expedia team that's now giving you JSON
by the
data
way,
files.
This is exactly what's happening right now. So I believe it seemed crazy to me to take a perfectly good database and make all this JSON gibberish out of it. But that's what we did, and now we're getting data directly from the system that doesn't write it to the database anymore. Guess what it gives us? Anybody? JSON! Exactly. It was brilliant. So I'm a believer at this point. Thanks, Anna. Go ahead. Pardon me.
And JSON's great. You know, it's lightweight, it's self-describing, it's a great way to share data. And physical files, you know, allows you to replay that data and then share it with other systems as need be. And the collection system that we built, you know, we can go ahead and deploy additional collection sentinels over to another, you know, SQL server or some other server to generate those files. So this is where we benefited from that loosely coupled interface. So what were some of the lessons learned in optimizations? Even though you are decoupled from your ingestion, it's important to look ahead to your transformation. So we're using Hadoop, and what we found was Hadoop does not like a lot of small files. So we ended up changing collection to create larger, less frequent files. And then we also found that we needed to do more distributed processing and intraday processing to ensure that we actually, you know, generated all the daily data in time for our nightly processing. And now that we are ingesting externally provided data, we've introduced a preprocessor. So we have insulated our ETL from malformed JSON or bad data. We actually look at that data and look at that data and reject bad data before it gets into the system. So once we collect the data, we now need to transform it and store it. And all this is done using Hive on Hadoop. So we have a Hive metastore and a MySQL RDS. And we have, those are external tables, so the data actually resides on S3. So what this means is we persist the schema and we persist the data, but our EMR we spin up when we go to do our nightly batch processing, and then we terminate it when we're done. So we don't have a long-running cluster. So this is where we're sort of embracing that impermanence of not keeping something running constantly when we're not using it. One of the things we haven't talked about is how quickly the team actually delivered the solution. It was a small team, and they were building a new data mart. We were up and running in production in 8 months, and a lot of that was due to the decision to use Hive and HiveQL, because you know, SQL is a pretty widely used skill set, and our team had a very good, deep understanding of SQL. So this allowed them to focus on learning new technologies, learning the cloud, while not having to learn a new language, and then write everything in MapReduce jobs. So this really enabled us to quickly get the solution up and running. There are a lot of lessons learned in optimizations when we're talking about Hive on Hadoop. One of the things that we actually ran into was the HiveQL was it's not SQL. So you couldn't just pick up your SQL code and run it on Hive. So there were some changes and some learnings there. We also learned to be careful with those AWS default settings on your Hadoop cluster. There's been a couple of times where we were successful in changing those configurations and improving the performance of our processing. But there was an instance where we set some memory settings, and what happened was we wanted to take advantage of that scaling out, but those settings then kind of bottlenecked us, and so we ended up taking those out and changing that so that when we scaled it out, it would actually perform better. So it's just word of warning, be careful when you're messing with those configurations. The other thing is those big files. So as you're inserting into your Hive tables, you're going to create a lot of smaller files. And as you process over a long time, your process will slow down. So we had a nightly run of 3.5 hours, and eventually we were slowing down to 12 hours. And a couple strategies for that is either to insert, overwrite your partitions, or have a maintenance that comes and reconsolidates those files into one big file. So all of this orchestration, as I mentioned, was done using data pipelines with the shell scripts and executing HiveQL. And we picked data pipelines. So it was kind of a natural choice because it's a AWS service that's meant to work with other services. And when we looked at it, it was very similar to SSIS, SQL Integration Services, and that's another skill set that the team had. One of the things that we quickly realized though is we had to customize it. We ended up making, we have a master pipeline, and we ended up spinning off a lot of child pipelines so we could process more things in parallel as well as have manageable chunks of code. So that's one thing we had to kind of customize quite a bit. The other thing we're using is Dynamo DB. So Dynamo DB is a NoSQL solution, and we use it for tracking the processing of our JSON data files and ensuring that each step of our ETL is followed. And this works really well because there's a Hive storage handler, so we can connect directly to it and run our Hive QL and query the Dynamo tables to make sure we're running the right files at the right step. One of the drawbacks, though, is as the table gets larger, it's a NoSQL, so you have a key and a store key. You can't add a lot of indexes. So one strategy that we've employed is to archive off the data, and when we start our nightly batch processing, we actually increase the Dynamo capacity, and then when we're done, we decrease it. So what we've done is improved performance and added some cost benefits. And then we get to information delivery. So our data mart is actually on S3 using Hive, and that data mart is then pushed to Redshift. We found that the on-demand and analytical queries against Hive using MapReduce, we were on MapReduce at this time, it was just too slow unless we created a really large cluster. It also meant that we had to have a cluster up and running the whole time. So the choice was made to use Redshift, and Redshift also has all those handy drivers, and it's easy to connect all sorts of reporting tools to it. And then as far as the loosely coupled interfaces, we implemented views. So all of our tables are abstracted using views, and what this allows us to do is when we do a release and we rebuild a table, we can do that and then verify the data is correct, and then simply repoint the view to the new table. So there's essentially no downtime for our users. The other thing that we've been able to do is scale Redshift. So we, on a Saturday, took about 7 hours. We doubled the size of our cluster. We got the cluster the whole time was read-only, so reports were still running. And it was completed before the nightly batch started. So we doubled the size of the cluster, which halved our queries with, again, essentially no downtime. The one thing that we're still struggling with is a replacement for those OLAP cubes. So this is one of those areas where we built some tables to try to kind of fill that gap, but it is one area that we're still kind of struggling with. So now that I've described the platform, you might be thinking, okay, well, why aren't you using Redshift for your transformation data store as well as your information delivery? And that's a good question. That's where we come in and have to kind of justify that complexity. And the reason being is we didn't want ETL and your analytics and reporting competing for resources. We're also a global company, so we're not necessarily guaranteed a safe ETL window. And then you would also be bottlenecking your data access. So now everyone has to access the data through Redshift. By putting it on S3, we can access it through now Amazon Athena. We could spin up like a Spark cluster. We could even access it through Redshift Spectrum. And as more and more serverless architectures or serverless services become available, we've set ourselves up so we can really get to that data in all sorts of new and interesting ways. Now, the component interfaces, those loosely coupled interfaces and impermanence, we talk about changing out technology. We talk about, again, impermanence, not having servers, maybe using serverless, maybe changing things out as technologies change. So what we could do is we could take our MySQL Hive Metastore and start using that fancy new data catalog. Or we could take out data pipelines and use Apache Airflow without having to rewrite all these other pieces of code. So I also talked about the prototyping of that information delivery, that high-risk component. So one of the things we did when we got to, well, we did a lot of prototyping, but when we did load the production level data, as Tad mentioned, there were some performance issues. And some of that was because we didn't load appropriate test data volume. So when you're going to prototype something like this, and you're going to use transactional data, load transactional data. Like, don't load aggregated data, and try to load it in volumes that you think that you'll be seeing in a year or 2 years, however much history you're planning on having. The other thing was to look at the bulk of the queries that you're going to be running against those tables and build your tables accordingly. You know, when you talk about Redshift or any sort of distributed systems, you really have to figure out how your data should be distributed, or else you're not going to be utilizing that parallel processing. And the other thing, the goal was to not have aggregated tables and to query the underlying fact tables. And what we found is that the performance, you know, from a user's perspective, just did not meet our expectations. So we did go ahead and implement aggregated tables to solve for that problem. And with that, I think Tad's going to talk about self-service.
All right, thank you, Anna. That was great. So Anna and her group are actually working on automotive car architecture, and so imagine that. A loosely coupled car, maybe the wheels are tightly coupled, but the rest of the car, and you can just take out that big V8 engine that's gas guzzling and throw in a new Tesla engine. So that's look forward to that in 2018. Not really. She's not going to do that. Okay. So I'm going to talk a little bit now about how we chose the products that we chose for the user interface, and how we use the cloud and the impermanence of the cloud to evaluate products. And I'm going to kind of compare and contrast this with on-premises solutions or on-premises testing of the same type of thing. And then also how we maintain familiar concepts, and exactly a little bit more about that, and our self-service methodology. So I'll start out with evaluation, our best practices for evaluation. So if you can imagine, you know, back in the day, again, me 3 years ago, and I decide, okay, I want to try a new user interface product. So I have to order hardware, I have to load it on my desktop, and then I have DLL contention and all these different things. Or I finally order hardware, I get it racked, I get it stacked, I get it loaded. It's 6 months later, I finally get to try my software out. In the cloud, I was able to requisition an EC2 instance, load the software I wanted to test on it, and I actually did load each of these different software packages. Then I evaluated those packages against business requirements, and then simply dropped the EC2 instance. No foul, no harm, and did it again. So this is one of those things that in the cloud happens so fast and so quickly and so easily compared to the paradigm of a few years ago. So as far as familiar concepts go, you can see here on the left-hand side, let's see, they told me there was a laser point. Oh, look at that. On the left-hand side, that's our legacy cube, the actual SQL Server Analysis Services cube. And on the right-hand side is the Tableau Datasource that we created. So you can see that we have, other than the measures and dimensions being flip-flopped, they're very similar. A user can open up the Tableau data source that's used the cube, the legacy cube in the past, and they'll say, oh, I get this. You know, they'll be able to figure out that the measures are on the bottom. They can probably figure that stuff out. So the way we did this is we used numbering, just like we had in the cube. So everything is sorted the same. So people start, they go in and look for things kind of in sequential order. So we use numbering in our folders, and then we use folders. Now, if you're not familiar with being able to use folders in a data source in Tableau, it's a great feature that we found very handy here. So we were able to, you can actually expand these folders, and then you have your actual dimensions in there, or you can even expand them and have a hierarchy within a folder. So this allowed us to basically create something that our users were very familiar with. They could open up the first time, I get it, I understand where the data is. The other thing that I mentioned earlier is calculated measures. So we spent a fair amount of time thinking about what are our KPIs, what are the things that we know all of our users are going to go in and want to report on every day. And then we built those, and we built them in a couple of different ways. We engineered the fact tables, as I mentioned before, and I'll give you an example of that. Actually, I'll tell you about it now. I think there might be a slide later. So in payments, there are a number of different operations. When you go to make a payment, we have to verify your card, and then to make sure it's really a card, and then we have to authorize to make sure you have enough money, and then we have to capture the money. There's all these different operations that happen. And what we did is we took all of those operations and consolidated them into a single record. And that record now has all the great attribution that we have, whether it's a Visa, a MasterCard, what country it came from, and so forth. But it's all one record, and we can determine easily through all those operations if it was a successful or failed transaction. We can also then tie it back to the actual fees that were charged for that transaction and so forth. But this allows us to have business, this is the business value we created within the data. The other thing that we did as far as keeping familiar concepts in Tableau Online is we created projects. We used projects in Tableau Online to sort of simulate folders on your desktop. So our users prior used Excel. They would save their pivot table or whatever they had created to their desktop, or they would share it with other people. We needed to maintain that same functionality, and we did it with projects in Tableau Online. And then our self-service analytics. So I mentioned a little bit before, we have parameterized reports, or your basic reports. These are great. Everybody knows this. There's nothing too ground-shattering about this. Pivot builders. I think this is kind of a neat thing that we did. So you can see up here we have row categories, and then we have measures here. So the users can actually select. We did this all with parameters in Tableau reports. So the users can actually select which measures they want, or row categories. I'm sorry, row categories would be the dimensions, and then which measures they want. So they can choose up to 4 dimensions and 3 measures, and then they've got a whole lot of different filtering and sorting and so forth that they can do on the right-hand side. This type of report is for our users that aren't quite ready to author a report from scratch yet, but they need something that we haven't yet written a report for, a parameterized report. So they can basically go in here and say, okay, I need to know what the gross booking value in the United Kingdom in July, something like that. And we don't have a specific report that would address that. And then finally, because we've engineered our facts, managed our metrics, and managed our data sources, we can allow our users full editable templates. And this is actually Tableau Online. I don't know if, is anybody in here using Tableau Online? 2? 2? So not too many people. Tableau Online is pretty cool. Tableau basically takes all of the administration, and they do it. So it's like Tableau Server in the cloud, but Tableau does all the server administration. They do all the patches, they put on the new software and so forth, and we use it. So this is actually the web authoring view. So you can actually use this. You can drag and drop just like you can in Tableau Desktop. It's very close to the same functionality as there is in Tableau Desktop. All right, so let me tell you a little bit about Tableau best practices and some of the lessons we've learned and some of the optimizations that we've come up with Tableau. So Anna mentioned a little bit about abstracting tables with views. And when, so we have these fact tables, and sometimes the developers, they put names that are
They're technical.
technical in them, and they mean something, well, they don't mean what we like them to mean, or maybe they mean something, but
They mean something.
yeah, so we put business names on them. So we do this all with views. And we actually abstract everything with views. We don't ever look at a table in a Datasource in Tableau. So we have, even if our dimensions are just, select star from dimension table, our fact tables, we will rename things, we'll do some aggregations and so forth in those. So definitely abstract all tables with views. Naming. So I guess I made a mistake early on with naming, and naming conventions are sometimes kind of hotly contested, and I've heard people have just really a lot of discussion about them. But I'm just going to say, if you're generic, descriptive, and readable, and when I say generic, so this, I'm going to tell you about a little mistake I made. I thought it would be cool to put the version number in our data source, because then when we brought out a new version, everybody would know, hey, we've got a new version. The only problem is with data sources in Tableau is that they live forever, as far as I can tell. They live as long as this one has. And so we're on version
144.
144 now, but our data sources still say 1.2.3. So don't put the version number in your data source. Did you want me to say anything else about naming conventions?
No, that's
Okay.
perfect.
Okay, some of the lessons we've learned, and by the gray in my beard, you can tell that I've been around a little bit, and if I don't tell you about the things that we did that didn't work so well, then you might do them as well. So don't try to extract 500 million rows of data into a Tableau extract. It's not going to work. Extracts are great, they work really fast, but your data has to be really highly aggregated. In our case, we found that unless we have our data aggregated at a monthly level, it may be different for you depending on how many actual transactions you have. Also, consider performance always. We have demanding users. Anybody else? Demanding users? And they come up with some really great ideas. Hey, we've got this report that's a weekly report, and we always show it as of last week, so we're showing full weeks. We don't want to show a partial week this week. And they say, that's great, but we really want to see how things are trending this week. So, we can do that. We're clever. We're Tableau clever. And so we put a little checkbox on there that they can look at the current week. Well, the problem is that little checkbox has to go out to the server and figure out what the date is and what's the date range and how's the date compared to this, is it this week, is it last week? And so it ended up running that date math a lot of times on the server. We found that then we could just put a regular date filter on there and tell users, if you want to look at last week, then slide the date thing over. If you want to look at this week, slide the date thing over. It ran way faster. So always consider that. You can be clever and you can be very, you can do a lot of things, but sometimes they will affect your performance. Edit XML to change the environment. So we had a kind of an issue with moving from environment to environment with Tableau data sources. So we have a QA environment, a pre-production environment, a production environment, just like everybody. And so with a Tableau data source, you point to that environment, and then there's really not an easy way to go in and just change where that's looking. Where even if the schemas are the same, you can't change that without kind of rebuilding the data source. So we found this kind of clever way where you can actually go in and edit the XML. And I don't know if there's any Tableau people in here that they might not really want you to edit the This is unsupported, completely unsupported, all those caveats and everything. But it's really very easy. If you right-click on the Datasource file and open it in a text editor, this is actually Notepad++. You can just search for where it says schema equals. Here it says prod B. I just change that to prod, for example, if I want to go from prod B to prod. And then I do a search and replace for everywhere where there's my old schema in brackets, and I replace it with my new schema in brackets. Save that and close it. And when you open your data source up, it will automatically be looking at your new environment. All right, Tableau optimization. So again, like Anna said, we originally, the original thought was, hey, if we can just keep the atomic level data, the lowest level of detail, and because Redshift is supposed to be super fast, we can just that way we don't have any maintenance, any overhead of having to aggregate data or in different ways and different things. So that was the original thought. But then the reality was we've got too much, we've got to aggregate it at some level. So we went ahead and did that. When you aggregate data, of course, look at it carefully, make sure that you're only including those fields in your aggregations that need to be in the aggregation so that you don't blow it out further than you need. This is something that I learned, and maybe everybody knows it, but assume referential integrity when you're creating a data source in Tableau. So in the Tableau data source screen, if you click on the data and then assume referential integrity, I think it may be there by default, but if it's not, it should be. You should select it. This will increase. Anna can really say exactly what it does.
Yeah, so your ETL should ensure your referential integrity. And by checking this box, Tableau is now not scanning all of the tables in your data source. It's now just looking at the ones you're actually querying. So it's a pretty important setting. That
was another one of those great things Anna did when she first came in. Again, consider performance when writing reports. I kind of already spoke to that. Data source optimization. So here are some ideas, some things that you can take away with you. Create calculations in your data source prior to publishing any calculations you want to do. Create hierarchies in your data source. Hide any fields. This is important primarily if you're making extracts. So hide anything that's empty or not used by anyone to improve the extract generation performance. This is basically the same thing that I talked about with aggregations. Set default properties, your number formats, comments, and so forth. And then any kind of data types and geographic roles. You also want to make sure that this is all done prior to publishing your data source. Oh, yeah. All right, so, wow, we finished right on time. So, payments are incredibly important to Expedia. You know, I don't know if you heard Mark this morning. He said, what was that quote that Mark Twain and anyway, payments are important to Expedia, and in order to be able to watch out for our effective payments and our efficient payments, we needed to build this data mart. And now that we have it, we've been able to increase our efficiency and decrease the cost significantly.
And from a technology standpoint, you know, our nightly processing runs about 3.5 hours, and we could, because we're on the cloud, we can scale up, make that faster, we can change our technology fairly easily. So we're really in a good space for being able to support any sort of future requirements. So just a couple takeaways. Think about those guiding principles. This is another thing that you'll probably hear at other sessions is architectural tenets, Establishing these guidelines, it's really important when you are doing a project, and also it's important to look back on as you just continue to develop and add new features. And so if you don't have them, go ahead and establish them. We have some you can take with you. Embrace the impermanence of the cloud. There's a lot of differences out there. If you don't need it, turn it off. Look into, obviously, serverless is a big thing. And as far as development, it doesn't have to happen in sequence. Everything's more agile. And we kind of started at the end and worked on a little bit of stuff in the middle and, completed a whole project very successfully by doing that. And as Tad showed, you're building all these new things, but make sure your end product is usable and it's familiar, because you want people to use it. And that's a really important part.
Great. Thank you all for attending today. Does anybody have any questions? Yep. There's a microphone here if you like.
Great. I really want to talk about the naming guidelines. I didn't see anything about consistency up there. No, we're building a data lake, and one of the challenges we see sometimes is with like calculations that folks would use for reporting. And I saw you talked about having like those metrics existing, saw both in the semantic layer and then as well as in the data layer. I was curious, like, what your thoughts were on how you decide where the appropriate place is for those calculations.
Yeah. So I don't think we've actually done a lot of calculations in the data layer. Yeah. Most of what we did there is engineered our facts. So we didn't actually do calculations. We did sort of consolidation in the data layer. Yeah. And then we tried to put the calculations that we knew that were really the business calculations as close to the business as we could. And we did those actually in the Datasource. Well, the next step closer would have been in the actual report, but since we wanted them to be available to all users to use, we did them in the Datasource.
Okay, cool. And I was also curious, like what execution engine you were using on Hive, like MapReduce, Tez?
Yeah, so right now we're using MapReduce. We're moving over more things using Spark, so using DAG, which you've seen a lot of performance gains using that. Because you can also hook Spark up to your Hive and use Spark SQL.
Okay, and then with data pipeline, you were talking about the future, swapping that out for something like Apache Airflow. I was wondering why you weren't thinking about another Amazon service.
I put that out there instead of Glue because I already had a data catalog up there. But there's a lot of choices, and I've heard.
I think we both kind of like those pinwheel things.
Yeah, the pinwheels were really pretty.
They were cool.
But I've heard a lot of good things about Apache Airflow, and Blue ETL is also a good option.
Yep, and then with that batch metadata, it looked like you have in Dynamo DB. Do you have the ability to roll back batches that you've processed?
That is it's not automatically, it's code. One of the things the Hive storage handler doesn't do is it doesn't delete. So you have to go through the CLI or through the interface.
Great, thank you.
Anybody else? It's a little hard to see up here. Yeah. Yes, sir. Yeah, step up to the mic. Thank you.
Does any of your transaction data have mutable properties? And if so, how do you handle it with a file-based system like Hive and S3?
Does any of it have
immutable properties?
Mutable. So are any of your transactions mutable? Do they change state so that you have to update some information? And if so, how do you deal with that in a file-based data lake?
Well, we stitch the data back together, right? So as we ingest the data, so if a transaction changes, then you have multiple copies of that transaction that you then load, and in your ETL you decide what you're going to allow to be updated and what you don't update.
So your initial, that's really loud.
Sorry.
Your initial extract is append only JSON. So when the transaction changes, you get a new JSON row for that same transaction.
Yeah.
Okay, cool.
Have you guys considered using the AWS DMS data migration service to move the MS SQL server to the SQL server to the Redshift or?
Yeah, so you mean the data that we're collecting from the on-prem SQL?
Yes.
Yeah, so that's not our database, actually. We're extracting data, you know, much like a lot of data, you know, BI organizations, we don't own the source data. And that team is moving to the cloud. And this is where we're getting, they're actually producing those JSON data files for us from a stream.
Thanks.
Did you try querying JSON files directly from S3 by using Athena?
Yeah. No, actually, no, not the JSON. We've actually done it with our Hive files. Actually, you know, I've used the JSON Survey to query the actual JSON files from Athena.
I mean, is it like the complexity, that's the reason did you choose EMR?
I'm sorry, say that again?
Is the complexity of JSON files was the reason for choosing EMR and Hive?
No, I don't think so. I mean, there's a lot of support for JSON. There's a lot of third-party tools and libraries that you can add to your cluster. There's a built-in JSON Survey with Hive as well. It's a little tricky to load nested JSON into Redshift, but it works pretty well with some of the other tools.
There was another question over here, too.
So it's again about JSON. A couple of things. How many different JSON structures do you deal with on a normal basis? And do you have any contract with the data provider team to get only certain structures, or you just deal with those as you get differences or changes in the structures?
Boy, am I ever glad Anna's up here. I got to tell you.
That's a really good question. Yeah, we have established data contracts. So we have a couple of different file formats that we expect. And that's really important, is to work with your data providers and establish a contract. With the data lake, you can, just kind of consume these JSON blobs of whatever anyone sends you. But if you want to really, have a solid ETL process, you need to establish those contracts.
Oh, thank you.
So we use a similar architecture like what you shown. The only difference is Redshift, right? From Redshift, we have our own deployed Tableau rather than Tableau Online, because we worried about the performance connection.
Oh, yeah.
Right. So how you resolve that? Because if you have the data sitting in Redshift and connecting from Tableau Online, there is a bandwidth issue going to play in, right?
I think the decision was to make our Redshift in the same region as Tableau Online, which helped with the data delay. And as far as I know, we haven't really had any performance issues.
Yeah, I don't think there's
with the
any
connection.
latency between, actually, Tableau Online is running on AWS.
Yeah. So
We're in the same region?
The same region.
Yeah, so we don't go cross region.
Got it. Okay. Thank you.
Sure.
Hi, you mentioned you're using Hive on Spark. Have you looked into Hive on Tez to improve querying performance?
Did everybody hear that?
Yeah,
okay.
we did look at Hive on Tez, and we ran into a couple of issues with a lot of our reprocessing. We clear out our S3 data partitions, and with the DAG, it was a little trickier to repair those tables and make sure that the partitions were showing up correctly. So I think that we're probably moving more towards Spark than Tez in the future.
Okay, thanks.
You mentioned storing the atomic data. They just stay on S3, or do you go ahead and load them into Redshift and also generate the aggregated data?
We only load the data mart into Redshift, so all of the landing zone data stays in S3.
When you load it to Redshift, are you flattening it, or you're loading it as a JSON structure and then doing something later when you query?
We're actually loading it, so at that point they're Hive tables, and they're in Avro format actually, and so which is actually pretty handy for loading into Redshift. It supports Avro, so it's a really easy copy into Redshift.
Okay, thank you.
Did you consider using Phoenix instead of Hive? I've heard it's more performant.
Using what?
Phoenix?
Phoenix? I don't know if that was evaluated.
Okay.
I'm not sure about that.
And can you touch upon security a little bit, especially for your batch? and getting it into?
Security for a batch. Oh, you know, we have a VPC, we have IAM roles. Our user accounts are connected to the federated IDs. Is that what you mean? Okay.
I knew you had another question in there.
Just one. I was wondering if, you know, with all like the new technologies coming from like, you know, the SQL Server reporting services world, I was wondering if you like took like an iterative approach at like initially trying to like maybe like swap out like Redshift and just like trying to use that as a data source for SQL Server reporting services rather than like doing like that and Tableau.
Yeah, not so much. I mean, we didn't go through development the same way that the data goes through the system. You know, like Anna alluded to, we actually said, okay, what's the overarching architecture that we're going to look at? Now, where are the high risk places? And the biggest one was Redshift. It was the biggest unknown, sort of. So we did load data into Redshift directly. We exported CSV files and imported them into Redshift, just for prototyping.
Yep.
And then we knew that eventually we were going to need to extract the data from SQL Server into JSON and go the end route. But we didn't really ever think about, because we wanted to have loosely coupled interfaces all the way around.
This also wasn't a migration. It's a new data mart.
Yeah.
Right.
Oh,
so
cool.
we weren't migrating.
Got it. Okay. And then I saw on S3 you had like ODS, you had Data Lake. Yes, Redshift. I was curious, like, how do you decide what users have access to what?
Engineers only.
Yeah, right. Nobody has access to anything.
Right now, not a whole lot of people are interested in looking at that S3 data. You know, analysts, we used Athena a couple times to get them, I think, direct access to some things on S3. But right now, it's all the access is really funneled through Redshift.
Great.
Yeah,
Thank you.
that will likely change in the future. I mean, we have people that just need data extracts and so forth. Or not extracts, but they just need, you know, hey, I want to know how many transactions there were in the world every quarter.
Right.
And we're not going to create a report and give them a Tableau license for that, for example. So we'll give them permissions to the ODS or something like that eventually, but we haven't worked that out completely.
If you were building this pipeline from scratch in an organization without an existing skill set, what's the title and the skills of the first person you would hire to get this thing started?
Anna.
Are you happy with your current employment?
Yeah.
I think that you need a database engineer or a database developer. You need somebody. I mean, anyone with database skills. I think this is a key skill set. Really.
Yeah, I think a lot of the technology that we used was chosen because of our existing skill set as well. So where you can do everything with Hive, and it looks like SQL kind of. You can also do that with MapReduce jobs in Java. So it kind of depends on what you want to do. So if you're starting from scratch with nobody and you need to hire somebody, is that what you're saying?
Correct.
Yeah.
Do you start with lower level implementation people or higher level visionaries people?
I think higher level visionaries,
Yeah, that's
definitely.
probably good.
Get those guiding principles. Get the guiding principles down, and then that will be clear. Then now you'll know, okay, these are the technologies, these are the principles, what technologies are going to support these principles, now what people are going to support those technologies.
Thanks.
You probably noticed that creating dashboards in Tableau requires you to stitch together multiple fact tables oftentimes, because
I'm sorry, multiple what?
Fact tables.
Yeah.
Okay. Well, I was just going to ask, like, how you represent, if you had to combine multiple fact tables, like, for example, you have, like 5 or 6 different metrics that all exist in 5 or 6 different fact tables, or maybe 3 fact tables, how you brought those fact tables together inside Tableau.
Yeah, actually, that's a great question, and I think I understand. And that's the value we brought. We don't have fact tables. We don't have situations where you need to pull data from multiple fact tables. I'll give you an example. We have merchant fee data where we have to pay all these people all this money to do the transactions. We actually stitch that together with the payment transaction, with the actual transaction that came in. So we say, okay, Visa's going to charge us $1 to do this $100 transaction. We're going to stitch it all together and make a fact table. So we don't have, we do that in the, do that in the ETL, so we don't have to do it in Tableau because it's way too big. We couldn't do that. And so now we have just that one fact table that has all the payment transaction attribution to it, what kind of card it was, you know, what point of sale it came through, and all that kind of stuff. And it also has all the fee attribution. So that's kind of the value that we added on creating the data mart.
That makes sense. Are you incrementally loading the Redshift data mart every day, or do you do a full flush and fill?
No, we call it kill and fill, but no, we do load it incrementally every morning.
Thanks.
You know what? We're all out of time. If you have another question, I don't know if there's probably another session coming in here, so we'll be in the hallway, like I said.